finished the test, or page 530, page 550 that we're going to talk about today, when you get to 13, 15, 17, it's kind of like questions 1, 3, and 5. They say evaluate the function for x is negative 6. That means when I look at number 13, I'm looking at negative 6. And wherever there is an x in the problem, I'm replacing the x with negative 6. So in 15, it says g of x. So this time you're going to put g of negative 6, and you're going to solve that. Questions 19, 21, this is like what we just finished doing, the factoring, okay? The reason we're doing that is it's leading us into this one. It says, use the knowledge and definition of a quadratic polynomial to make a conjecture for it. Well, obviously, after today, you're going to have a better idea on that. So you should be able to answer number 25. 26 says graph of quadratic. The graph of a quadratic is going to be U-shaped. So that curve has an axis of symmetry. What does that mean? Again, we're going to talk about that in today's lesson, so you're going to easily be able to answer that. And then you're going to ask to do this question. This we are not getting to till later, but they want you to take a look at that problem. So that's page 543. If you look in your notes on I1, what is a quadratic function? So what we are looking at today, on the top, the I can statement. So I can sketch a quadratic graph. We're going to start that today. Identify x and y intercepts. X-intercept is when it crosses the what? X-axis, right? That horizontal line. Y-intercept is where it's on the y-axis. Points on the y-intercept are always 0 with a y value. Points on the x-intercept are always number, like 7, and then a 0 for the y-coordinate. Okay? We're going to be talking about the maximum and the minimum of a function. Please keep facing forward for some of you. We're going to explain what those look like for our vertex. So quadratic functions, kind of like absolute value, have a vertex point. Okay, we're going to be identifying that vertex in our quadratic today in class as we go through. So a linear function. They were functions of our first degree. That's that one that I asked you to graph. A lot of them, remember, y equals mx plus b. That's linear. Why? Because the x is to the first power. You might remember point slope form. Y equals m, x minus x1, right? Plus, if we were looking at that, plus y1. So when we did slope intercept or point slope form. So it said they came in 3 forms. Our standard form, point slope, sometimes called our linear vertex. We're going to keep using that again. And slope intercept. Each equation had benefits of using that model. Quadratic functions are going to be modeled with second degree. So that means we have to have an x to the second. That makes it quadratic. And when it's an equation, it's usually y equals. Now, could it be like the ones we just finished factoring, where it's ax squared plus bx plus c? It could be that long. So standard form of our quadratic, the 3 forms, is when it's written with a second degree going in descending order. Factored form, aka that's our intercept form. We'll get that in this unit, but not right away. We're just going to kind of start with standard form. And then vertex form. So vertex form is identical to our point slope form. Sometimes it's called linear vertex form, point slope form, all of those different types. So we are going to be taking a look, and if you go to like the Desmos calculator on your computer, and you want to check and see what these equations look like. So it says, let's look at standard form of a second degree polynomial. Always has to be in descending, like the examples below. So when we take that test tomorrow, always in descending order, right? Your 3x squared minus x plus 8, 1/2 x squared, always in descending. It says when you graph a quadratic function, you get a curve that's called a parabola. Parabolas can open up or down, but never sideways. Okay, that's going to be later when you look at those. To graph a parabola, you're going to pick 4 or 5 inputs. Those are your x values. So kind of like that absolute value one where you pick from 2 to -2, -1, 0, 1, 2. You're going to do the same thing with this. Okay? You're going to pick those 4 or 5 values for x, and you solve for y. Then you'll plot your points. Key concept at the bottom of this page down here is when we are looking, I'm always going to be asking you to tell me the axis of symmetry. And a lot of times you're going to see me abbreviate it as the AOS. So what's the AOS as you're doing the problem? That's the axis of symmetry. So when we are looking at that, for quadratics, notice it says it opens up if A is greater than 0. Just means A has to be a positive number, right? When A is less than 0, meaning it's negative, that parabola is going to go down. So it'll always open up. If A is positive, it'll always go down if it's negative. That vertex, when it opens up, is a minimum. So I'm going to ask you in your homework today, is it a minimum or a maximum? This one, if the graph opens up, if A is positive, we'll always have a minimum. If A is negative, you will always have a maximum point at the top of that. Okay? So, on the top of the next page, on top of page 2, you are asked, as you look at this, find the vertex. The vertex is an ordered pair. So if I am going to write, in the first one, I would write my vertex. And I am looking specifically at this point right here. Right? The point right at this point. So my vertex would be at 0, 3. The next thing it asks me, is that a maximum or a minimum? Pretty easy. It's a maximum, right? Next thing, write the equation. Oh, I can't just say it axis of symmetry. It has to be an equation. That's this line that goes right here. That axis of symmetry, since it's a vertical line, is x equals, and what is my x coordinate of my vertex? X equals 0. So what I want you to do for the next two, I want you to tell me the vertex, and I want you to tell me minimum or maximum. Don't worry about the axis of symmetry. So the vertex, tell me that point, your axis of and if it was minimum or maximum, then we are going to look at that axis of symmetry in just a minute, okay? So, write what you think. Check with Joel's starting us off. Vertex of this second picture going across here. 1, -1. If I am looking, was it minimum or maximum, Christian? It was a minimum, right? It's the bottom of that line or that curved graph, minimum, okay? If I go down to this one, Lulu, what am I looking at for my vertex? -2, -3. If I am looking at that, at least minimum or maximum? Minimum of that. I am going to be looking for my equation for an axis of symmetry. It is always x equals when you start your axis of symmetry. Always x equals. So then you are looking at the vertex, the x coordinate of the vertex. So Angus, my x coordinate of the first vertex is x equals 1. Benson, my x coordinate of the second of this vertex is -2. Later in this unit, we are going to talk about these special numbers right here. So as we go through this unit, we are going to talk about this point right here and this point. Those would be called our what? Since they're on the x line, they're called the x. What would we call them? X. What did we say in the beginning, the I can statements, that we can identify x what? Intercepts. These are my x intercepts, right? Those are going to be close to our solutions when we go through. At this point, just so you're recognizing this. If I was looking at this point right here, what would this point be called? This is my y-intercept, right? So just so you're making sure you know where the difference between an x-intercept and a y-intercept. Why didn't I do these x-intercepts? Because they're kind of like halfway points. But these are still, these 2 points right here are still going to be my x-intercept, right? Okay. So just so you understand where x-intercepts, y-intercepts are as we're looking at those. So this is how you're going to do the graphing when I hand out the graph paper. So it says, here is our function y equals -3x squared. Question is, we're asked always, what is the domain and range? See, I told you it wasn't going away from earlier this year. So we're going to make a table. Usually, I'm okay if you pick 5 values. So -2, -1, 0, 1, 2. You want to make your table. When we are showing this work, we are going to take y equals, and we're going to take -3. And we said x, please write this in, -2 squared. When I square negative 2, Aiden, I end up with what?
Negative.
No, when I square negative 2, I end up with what? I can't be negative 4. I'm taking negative 2 times negative 2.
It's 4.
Oh, did you say 4 or negative 4?
And then 4.
Oh, you meant 4. Okay, I thought what I heard, so I was just checking. Okay, so we get 4 times negative 3, which means this is negative 12. Write the ordered pair. The ordered pair is negative 2, negative 12. Okay? Freddie, we're going to substitute in the next one. We have negative 3 times, we're replacing our x with negative 1 and squaring it. Negative 1 squared is?
1.
1 times negative 3 is going to leave us with?
Negative 2.
Negative 3. So my ordered pair is negative 1, negative 3. Could you start plotting those on your graph at the same time? Yes. Okay. If we continue with that one, Caleb, putting in 0. Don't you just love 0 on our tables?
Yeah.
Yeah. Caleb, what are you going to get?
Negative,
One for
negative 3.
We're going to get what?
Negative 3.
Wait, times 0?
Oh, no, 0.
Okay, good. So it's 0, 0, right? So I know 0, 0. And the key thing about these is that we're always looking at our graph. So, Kellen, if we are going to be taking a look at that next one, we have negative 3, and we're going to take it times a half squared. What is a half squared? 1 over, when you square 2?
4.
1 over 4. So I have 1/4 times negative 3, which is going to leave me with negative 3/4. So my ordered pair is 1/2, negative 3/4. Hayden, we're going to substitute in 1. Negative 3 times 1 squared gives us negative 3. So at 1 we have negative 3. If we are continuing, Jack, with the 2, negative 3 times 2 squared. Right, 2 squared is?
4.
And I think you were thinking of adding, and we are multiplying.
Sorry. Negative 12.
Negative 12. So we are going to have our ordered pair be 2, negative 12. So please plot your points, right? Negative 2, negative 12, negative 1, was it negative 3? Kind of a very narrow graph, right? We are looking at it. Where is that 1/2, negative 3/4, like there, okay? So as you are looking at those, and then you are going to draw a curve. This will definitely be a curve when you take a look at it. So you want to curve it, and it should always not be, absolute value was definite 2 lines. It was a V shape. This is always going to be curved. And what you're looking at, which is really nice, is a lot of times in your table, if you get one side, like if you get this answer is negative 3 and this is negative 12, once you have the vertex, it's exactly symmetric. So you might not even have to do the work to finish solving it. So the domain, what kind of x numbers could you continue to put in? What kind of x values can I think of that I could use in this? Could I use negative 720 for x? It'd be an ugly number on my graph. Can I use 503? Could I use 5.792? So what kind of numbers are we talking about for our domain? They're called what numbers? No, they're not just integers, because I gave you some that were not integers and 1/2 is not. We can do it all
Rational.
not even rational, all real numbers. Domain, that would mean any number I can put in for x is going to be a real. But when I get my output, my range, what's the biggest number I can have? No. What's the biggest number? I can keep going all the way down here. What's the biggest one? 0. So I'm going to say all reals less or equal to 0, right? So this is where a lot of times when we were writing domain and range before, we used this for all reals. And then we said where y is less or equal to 0, okay? So you can write it either way. You want to write it mathematically. So if you remember when we did absolute value, domain and range, this is where, how does the A affect the shape? What does it do?
The smaller the value is, the larger it is. The lighter it is.
So the smaller, meaning fraction decimal, the smaller, the more it's close to 0, the decimal or fraction, your graph is going to get wider. the bigger the A value is going to be, the bigger or larger that that A value is going to be that it is going to get narrower. So when we are taking a look, the closer A is to 0, the wider, okay? So that's why when we were looking at it, 1/12, the yellow graph was very wide compared to the yellow one or the green one at 1/3. And as it gets bigger, that's why our graph for that -3 was really kind of very narrow, because anytime that number gets larger, and it can be a larger positive or negative, just greater than 1 or less than 1. As it gets bigger, it's going to get narrower. So does the sign affect, the sign of the x squared affect the parabola width? No. The sign makes the parabola go down or it goes up, right? So down is going to be for our negative values, up is for our positive values. So now we need to look at what changed this time. What's the same in all of these equations? So again, I don't know if you need to write the colors or you just put like this is yellow, blue, red, and green, so that you kind of have, as you're looking at your notes and you're going, oh, x squared, notice is at 0, 0 for the vertex. What do we notice about the yellow graph? Where's the vertex at for the yellow graph or gold one if we are looking up here? Where is the vertex for that yellow and gold graph? Down at 0, -3, and look at the equation, x squared minus 3. And we look at the green graph, the vertex is at 4.5, and look at the equation, x squared plus 4.5. And the red one, plus 2. So, Angus, do you have something you want to tell me? The question, how does the C affect it? Does it affect the shape?
No, it affects the y-intercept.
It affects the vertex point. And it does affect the y-intercept, so when we are taking a look at this one, if we are thinking about that rule, what can we say? We are going to say that when we take a look at that, the C determines our y-intercept. This is only when you don't have a lot of other, like you don't have an x term and you don't have a, when we are looking at plus a number, but if it's just the C value, that determines our y-intercept. It also helps us look at our parent function. It moves it up and down. So the parent function is the y equals x squared. That was the blue one. The C is going to move it up and down on that one. Picture that an acorn is dropping from a tree branch 70 feet above the ground, and it says that the function is this, -16t squared plus 70. So the 70 stands for how high off the ground, right? That's where it was when it started, up within the top of that tree, 70 feet up, okay? And we're looking at how much it's falling in seconds, so height per second. And it says, what is the graph of this function? And about what time do you think it's going to hit the ground? Okay, so we're going to start off at 0. If you plug 0 into this equation, -16 times 0 squared is going to be what? 0. So plus 70 means we are going to get 70. Plug in 1. So we're going to be thinking it's -16 times 1 squared. Well, that's just -16, right? Plus 70. -16 plus 70 gives us 54. How do we get the next one? You're going back to the original equation, h equals -16. You're going to put in 2 squared plus 70. So 4 times 16 is 64, right? That's -64. Plus 70 is going to give us.
Oh, sorry.
Right. So -64 plus 70.
Oh,
6.
that's it. I wasn't.
Okay. The next one at 3 seconds, -16 times 9, 3 squared, plus 7. By all means, use your calculator. Positive 9 times -16 plus 7. So, -74. So we're going to plot the points. 0, 70, right? 0, 70, that's where it started. After 1 second, it already fell 54 feet. Well, we'll estimate where 54 is. At 2 seconds, it's at 6. Well, this is 10, so about here. And at 3 seconds, we're not gonna plot that, right? Can it actually go down if you drop an acorn? Does it go down into the ground negative 74 feet? Is that even possible? It sits on the ground, right? If it falls off the tree right now, it's just at 0, right? So, this is not any kind of special acorn. So, right, we're gonna have something like this as you are drawing it. So try and draw that curve. So if you were gonna estimate when it's gonna hit the ground, what might we be thinking about?
2 seconds.
But probably, well, it isn't 2 seconds.
One.
So like you can estimate that, right? We can check, but we're not gonna do that right now because the part on the bottom asks you to kind of take a look. So that last page of your note says, if you look at the graph and table, when does the acorn hit the ground? What would we say about what? When did it hit the ground? At about how many seconds? Like 2.1 or 2.2 or a little over 2 seconds, right? So I don't need you to write down all this. I'm just going to put it up here. It's a lot to read. Don't write it all down. What would we put? I would just put this part. A little more than 2 seconds, right? How do we know that? Well, 3 seconds, it's under the ground, right? And we actually can't go under the ground. Okay, so I would say a little, when do you think it's going to hit the ground? A little more than 2 seconds. Could you estimate it more than that and say 2.1 or 2.04 or 2.2? Yes. It says, why do negative values represent why do they represent that negative? Again, a lot to write down. The key thing is that I want you to put down, negative would represent height, and that would be trying to tell us below the surface. And that isn't possible. You can't go below negative 74 feet. It is not like a rocket shooting down into the earth, right? It is just an acorn falling off a tree. It's not moving if we are looking at that, right? It hits the ground, it's not going. And then the last one, what would our domain be? And this is going to be just a little different. So when I am thinking about my domain, the domain, it can't be all reals this time, can it? It has to be all real numbers where x is what? Greater than or equal times 0, right? All real numbers. This is the symbol for all reals. I'd like to write out all reals, Lizzie. Write that out. 2 lines with an R. All right. Now, tell me something. Is it just x greater or equal to 0? Can I go 3 seconds? No. So we're going to say x is greater or equal to 0. So remember when we did those, we kind of wrote it in between. And we'd say approximately more than 2. We'll be more specific later. Like more than 2 what? Like 2.1, something like that, right? What is our range? What was the highest up? Where did it fall from? 70 feet. So again, all real. Okay. What's the lowest the y goes? Wait, when it hits the ground? 0. So this is our y values. The tree could be at 70, right? Stays in the tree, doesn't fall. All the way to 0. All real numbers. And this is talking about the height. Key thing, the range is the height of the acorn. And the range is the time in seconds. Okay, so making sure you're understanding what those two mean. Okay?